Alright, so in this video I'm going to look at speed time graphs. Okay, so they look like this. They look like the distance time graphs that we've already done. So they look like these ones. Alright, but how you read them or what you can read from them is a little bit different, and it's very easy to get them mixed up. So I'm just gonna compare them first. Maybe just run through these again, do one quick example on these, and then do a couple of examples on the new thing. Okay, so these new ones are graphs of speed against time. So what is on this vertical y-axis is speed, and what is on the horizontal x-axis is time. So speed time graphs. What we did before was distance time graphs. So distance was on the vertical y-axis, time was on the horizontal x-axis. Okay, so this was distance. So when the graph was moving upwards, that was you moving distance away from where you started. When the line got horizontal, that means your distance was staying the same, so you were stopped, you were stationary. And then if the line started going down again, that meant you were traveling back towards where you started. So your distance was going to go back to your starting point. Okay, so I'll just run through one of these distance time examples before going on to the new thing, the speed time graphs. So this question here, Daniel went walking, he walked along a particular route, returned by the same route. The graph shows the different stages of his walk. Okay, so we have down the bottom time, 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. There's 1, 2, 3 kind of boxes or markers between each hour. So that means each of the boxes is 20 minutes. So there's 3 of them between each hour, each of them is 20 minutes. And then on the y-axis, I've got distance from home in kilometers. Okay, so what this graph is telling us is Daniel leaves home at 12 o'clock. He travels at a steady speed, so a straight line means the speed is staying the same. He's traveling at a steady speed away from home until this point here when he stops. Okay, so we know he stops because the line becomes flat or horizontal. All right, so he stops at 1 o'clock. So that means he travels from 12 o'clock to 1 o'clock and he reaches the 5 kilometer mark. So he's traveled 5 kilometers in 1 hour. So the speed there is 5 kilometers per hour till he gets to here. Then he stays still. Okay, he's stationary. For how long? It's 2 of those blocks. So I said there 20 minutes at the start. So for 40 minutes, he's just stopped at the 5 kilometer mark. Then the graph starts going up again. So he's moving again. And he goes from the 5 kilometer mark to the 7 kilometer mark. So this is him traveling 2 kilometers. How long does it take? Well, it's 2 boxes. So again, we said each box is 20 minutes. So that's 2 kilometers in 40 minutes. At this point here, it goes horizontal again. So again, he has stopped. Okay, so at the 7 kilometer mark, he stops for a while. It's 1, 2, 3 boxes. So that's for an hour that he is stopped. And then the graph goes down again, okay? So the graph going down means he's traveling back towards where he started, okay? So doesn't mean he's going backwards or anything like that. It means he's traveling back towards the point where he started, and he goes from 7 kilometers back to the 0 kilometer mark. So we travel 7 kilometers here, and he starts at this point. So it's 1, 2, 3 boxes, so it's an hour. So he goes 7 kilometers in an hour. So it's another one where the speed is nice and easy to calculate. 7 kilometers in an hour, he must travel 7 kilometers per hour. Okay, so that's how you read these ones. So upwards, traveling away from where he started. Downwards, traveling back towards where he started. Flat means he's stopped. Okay, a couple of other things we need to be able to quickly tell from these. The steeper the line, the faster he's traveling. Okay, so just looking at this line here versus this line here, this one's definitely steeper than this one. Okay, so he's traveling faster at this bit than this bit. Okay, it can be harder to read when they're going up versus down, but this line here looks steeper to me. So I would say he's traveling faster here than he is here. Okay, you can actually fully correctly work out the speed to know for sure. Okay, so that's, and then again, if you need to fully work out the speed correctly, it's just the formula: speed equals distance over time. Like I said, they're nice and easy here. So from, say, this point to this point, he's going from 7 to 0, so that's distance of 7, and he's going 3 blocks along, which is 1 hour on this. So 7 over 1 is 7 kilometers per hour. Okay, so that's his speed. So it might be over 1 sometimes. You might have to actually do some calculation, but that's how you do it. You just get start point, end point of a line, how far has he traveled and how long did it take, and that's how you work out speed. Okay, so that's a distance and time graph. Okay, the new one that we're going to do, and like I said, they look exactly the same. Okay, when you just glance at them, you need to read what's on this axis here and maybe read the little bit of text they give you at the start of the question. But this one is speed versus time, okay? And it just kind of changes how we'll be answering the question slightly and what we can read from the graph. So because this is speed versus time, when the line's going upwards, it means the speed is increasing, okay? So speed is on the vertical y-axis. So if the line is going up, it means the speed is going up. So your speed is increasing. All right, so on these distance ones, it meant distance was increasing, and the straight line meant speed was constant, it was staying the same. These ones are different, okay? Speed is increasing because it's speed here. When it goes down then, opposite, speed is decreasing, all right? The other change then is a horizontal line on these ones means you're staying at the same speed. Okay, so it doesn't actually mean you've stopped in these questions. So a horizontal or a flat line in these means speed is staying the same. So that's when you're traveling along at the same speed. Okay, so on these speed and time graphs, we can't really show someone stopped, bar bringing them right down to 0 kilometers an hour. Okay, so that's the only way we'd have it showing someone stopped. So the horizontal is not stopped. So I'll just run through the 2 examples in the book, and then we'll give you questions to do on them. So example 1 here, graph below shows details of a train's journey as it travels from one station to the next. And if I ever see a graph like this in an exam, I check quickly what's over here. Okay, it's a speed one, it's not a distance one. So speed against time. Part 1, describe the progress of the train during the 3 stages A, B, and C of the journey. So just give as much detail as you can. So stage A, what happens? Well, stage A is from 0 to 10 minutes. Okay, so train travels for 10 minutes and the line is going up, so speed is going up. So for 10 minutes, the train speed increases until when? Until it reaches 80 kilometers, and then the line is going to go flat and we're into the next stage. Okay, so stage A, for 10 minutes, the train increases speed, or the train's speed increases from 0 kilometers per hour to, it stops at 80 kilometers an hour. Okay, and it starts at 0 minutes as well. So you could say for the first 10 minutes of the journey as well, but that would be fine. Stage B then, so what's happening at stage B? So from 10 minutes, so stage B starts at 10 minutes and stops at 20 minutes. So 20 minus 10, that's 10 minutes. What happens for 10 minutes? It's traveling at 80 kilometers an hour, okay? So it's flat here at the 80 kilometer per hour mark. So for 10 minutes, the train travels at 80 kilometers per hour. And then stage C, so stage C starts at 20 minutes and finishes at 25 minutes. So this is only a 5-minute section of the journey. And what happens? The train speed goes from 80 here down to 0 here. So for 5 minutes, the train's speed decreases from 80 kilometers to 0 kilometers per hour. So, or slows to a stop if you want, because when it goes 0 kilometers an hour, that's when the train is stationary or stopped again, because its speed over here is 0 kilometers an hour. So for 5 minutes, the train's speed decreases from 80 kilometers per hour to 0 kilometers per hour, or decreases from 80 kilometers an hour to a stop, because at 0 kilometers an hour it's obviously stopped. So I'm putting in how long the stage is, what happens at the start, so going from 0 to 80, from 80 to 80, from 80 to 0, and just what's actually happening, so increasing, decreasing, travels at, you can say, a steady speed of 80 kilometers there, or a constant speed if you want as well. All right, so that's that journey described. Part 2 then. So what was the train's highest speed during the journey? So the highest point the graph reaches is along here, and the speed is 80 kilometers per hour. So for the highest speed, just find out what's the highest point the graph reaches and read over, and that's 80 kilometers an hour, and that's you done. Okay, so you're asked for speed and the graph gives you speed, so you just read it off as 80. Okay, and part 3 then. So this one's a little bit trickier. So how far did the train travel at its highest speed? So how far did it travel? How far means distance, okay? I know that it traveled at 80 kilometers, and I know it traveled for 10 to 20. I know it traveled 10 minutes, but neither of that is how far. Okay, it's telling me what speed, and it's telling me how long it was at its highest speed. So for how far, I need to get distance. Okay, how do I work out distance? Well, it's speed over time. Okay, no, it's not. Oh no, I should actually write out the formulas here. That's wrong. Okay, so what's the your dad's silly triangle? DST, so D is on top. Okay, so speed will be distance divided by time. Time will be distance divided by speed. Distance is speed multiplied by time. Okay, so that was one a few people got wrong when we were doing just speed, distance, and time questions as well. Okay, so distance is speed multiplied by time. So there's an example of why it's always a good idea to write the triangle out, because it's really easy to write the formula then wrong when you're just going to remember it. So distance is speed multiplied by time. So speed is 80. Time is a bit tricky here because it's going from 10 minutes to 20 minutes. Okay, so the speed is 80 kilometers an hour. The time, though, is from 10 minutes to 20 minutes. So the time is 10 minutes. Speed is kilometers per hour. Your time is in minutes. So you can't mix per hour and minutes. So we spent a bit of time on this where we need to change this into hours. Okay, so you have to write it as either a fraction or a decimal hours. So what's 10 minutes as a fraction of a full hour? It's 10 over 60. Okay, because there's 60 minutes in an hour. So 10 minutes is 10/60ths of an hour, which is 1/6 of an hour. You can get it as a decimal either. Decimal's giving me 0.166666. I would say, so 0.167 maybe rounded off. I'd say you're better off using the fraction here, because if you're rounding off, you might throw off your answer a little bit. Okay, so just returning to it, distance is speed multiplied by time. So my speed is 80 multiplied by my time is, I'm going to use 1/6. Okay, so 10 over 60, or you could use 0.167 as well. So 80 multiplied by 1/6 is 13 1/3, 13.33 kilometers. Okay, or 13 1/3 kilometers as well. Okay, if you want to write it as a fraction. All right, so that's you done. All right, so first thing, as I said, just make sure you get that formula right. So write down the triangle and just which one am I looking for? Distance. So speed and time are on the same level. So it's speed multiplied by time. All right. We had the complication here that the time was in minutes, so I needed to change that into hours. Okay, so to change from minutes into hours, you divide by 60. All right, that comes up in these questions a lot because you're generally doing speed in kilometers per hour, whereas you get your time in minutes sometimes. All right, so that's that one done. All right, so what was different? I suppose the way we might describe the journey is a little bit different because it's speed there. Reading the highest speed off was fine. Getting the distance, we've done that before on these graphs. Okay, so on the distance and time graphs, it's speed they ask us to calculate. On these ones, it's distance that we have to calculate. So we just have to recognize that it is a speed graph rather than a distance one. All right, so I'll go over and do example 2 here. And then I'll give you some questions to do yourselves. So graph below shows some details of the journey Holly made by bicycle. So again, it's speed in kilometers per hour, so speed on the vertical. Holly waited for her friend before she set off on her journey. Part 1, how long did she wait before setting out? Okay, so how long is it before the graph actually starts moving? Okay, so there's the 0 minute mark, but it's 5-10 minutes before the graph starts actually moving. So it's 10 minutes before she starts moving. So that's when she actually starts her journey. Okay, so this is her at 0 speed, so she's still, and it's 10 minutes before she starts. Part 2 then, what was Holly's highest speed during the journey? So highest speed is just go to the highest point. It's here, and then read off. That's 25 kilometers per hour. All right, so there's the highest point, and there's, so part 2, 25 kilometers per hour. Just to fit in. And part 2 then, what was, part 3, for how long was Holly traveling at her highest speed? So for how long is time they're looking for. So I'm just going to read this off the graph. So her highest speed is this bit here. So from this point to this point, so that's from 30 minutes to 45 minutes. Okay, so 30 minutes to 45 minutes. So starts at the 30-minute point, ends at the 45-minute point. So 30 to 45. What's it actually ask? How long? So 45 take away 30 is equal to 15 minutes. All right, so there's your answer. If it asks for how long, it wants you to actually subtract them. Part 4 then, how far did Holly travel? So again, how far, they are looking for distance. Okay, so I don't make the same mistake I would have made on the other one. If I do my DST triangle, how far, I'm looking for distance. So distance is speed multiplied by time. Okay, so again, if you're looking for speed, it's distance over time, distance divided by time. If you're looking for time, it's distance divided by speed. But the other one then, distance, when those two, speed and time, are on the same level, that means you multiply them. So distance is speed multiplied by time. So my speed is in kilometers per hour. Okay, so it's how far did she travel at the highest speed? So the highest speed is just 25 kilometers per hour. The time then that I have for how long did she travel is 15 minutes. So this is another one where I need to change my time into hours first. So I don't want to mix up hours and minutes. Okay, so your time then is going to be 15 minutes over 60 minutes in a full hour. So just do 15 over 60 on the calculator. And that's 1 over 4. Or else 0.25. So you can use either one in your calculation. So distance is equal to speed multiplied by time. So it's speed so it's how far did she travel at the highest speed. So the highest speed was 25 multiplied by either a quarter or 0.25. It doesn't matter which one you use. So 0.25 multiplied by 25 is 6 6.25. All right, so your distance then is 6.25 or 6.25. You can write it either way. That's how far, so it would be kilometers. Okay, so that's two speed and time examples done and just contrasted with the distance and time one that I went through. Just really quickly, say in the question one that I'm going to give you to do, describe the progress of the train during the 3 stages A, B and C of the journey. So this is just like this example I've done here. So speed is increasing for how long? From 0 to 5, so for 5 minutes. Starts at 0, ends at 100, okay? So all that detail in. So just the 3 stages of the journey. So it'll be very like this question here. What was the train's highest speed? So that's exactly like the second part of this example here as well. 3, then how far was the train traveling at that speed? So again, it's just like the part 3 here or the part 4 here, where you need to use the distance and time formula, but also you might need to change your time into like a fraction of an hour or a decimal of an hour by dividing by 60 before doing it. But it's very like the first example, all right, and parts of the second one. This one here then will be very like the second example. So just look back at the video a couple of times if you need to as you work through these questions.